Hello, everybody, and welcome to this Mathigon webinar called Polypad Introduction Secondary Level. My name is David Poras. I am the head of content at Mathigon, and I am super excited you are all here, either joining this webinar live or watching it after the fact. Hello, Em. Thanks for introducing yourself in the chat. Perhaps South Carolina, is that what SC is standing for? I would love to hear from folks who are joining us live on this webinar. Please introduce yourself in the chat. Let us know where you are in the world and maybe your role in math education if you like. We'll get started at around 1:02 East Coast time. I am outside of Boston, Massachusetts, on the eastern side of the United States. And so about 2 minutes past the hour, we will dive in. Again, welcome to everyone who is just hopping on to this Polypad introduction webinar focused at the secondary level for middle school and high school students in the at the secondary level in school. Hope you are excited to learn about how to use the Polypad tools. Hello from France. Welcome to have you aboard. I'm actually going to southern France in a couple weeks with my family. David from Newton. I'm coming at you live from Newton. Welcome from Newton. I'll assume that's Newton, Mass, unless you correct me. Yes, you just did. Newton, Mass in the chat. Hello from Oregon. Hot in Houston, Texas. Yes, it is hot outside of Boston today, but I'm sure not as hot as it is in Houston. Hello from Daytona Beach, from North Andover, Mass. Awesome. Another minute or so, and I will dive in. Great to know we have a little bit of an international crowd with us today and other folks joining as well. All right, let's dive in. It is 2 minutes past the hour, so I am going to jump in. Let me pull up my screen here. All right. Again, I'm David Poras. I am the head of content at Mathigon, a mathematical playground. I also just finished up my 22nd year teaching 7th grade math outside of Boston, Massachusetts. Everything on Mathigon is free. So everything I'm showing you today, totally free for teachers and students around the world. It's free to make teachers account and students account. You can even play around on Polypad and Mathigon without an account. But if you do want to save your work and share some lessons with students and view their work, it is best to have teachers and students accounts. Lots of things on Mathigon. Again, it has courses and manipulatives and a timeline of mathematics and puzzles, but we are here today to learn about Polypad. So right here, I'm at mathigon.org. I'm going to click on this blue button to launch Polypad. You can also just go to polypad.org to get there. And this is our blank open canvas for exploring mathematics. I'm going to go through really a how to use Polypad in this webinar. This is for folks who are really new to Polypad. If you are a power Polypad user and you know how the interactions work, this might not be the best webinar for you. You could go to mathigon.org/learn and view some of the other webinars that really do a deep dive into a topic, that have a lot of teaching ideas and deep explorations into specific topics that you can explore on Polypad. The goal of this webinar is an orientation to Polypad. I'll certainly be sharing some ways I've used it in my classroom and ways you can use it at the secondary level. And so this is the right place to be if you are new to Polypad and hoping to learn more. So again, here we are at a blank canvas for exploring mathematics. There is a toolbar at the bottom. I'm going to call this the toolbar. There is a settings bar on the right-hand side of the canvas. And then here on the left is the tile menu where you can add a manipulative to the canvas. This white open space I'm going to be calling the canvas. And the first tile I want to add is this red hexagon. I can click and it adds it to the center of the canvas, or I can do a click and drag it onto the canvas as well. I'm going to use this plus button on the side to zoom in a little bit, just so to make these a little bit bigger. And the other thing that you may notice, when I select a tile, an action bar appears on the canvas. So when I click on this hexagon, I get this action bar. One action that appears for every tile is this copy option. So I can click it and I can make a copy of the hexagon as well. I copy tiles a lot on Polypad, and if you use Polypad a lot, I think you'll find yourself copying tiles a lot. The other way to do it is just with the C button on your keyboard. So I'm going to click C. Hello, Susan from Newton, Mass as well. We could do a meetup in person in Newton after the fact. That's awesome. All right, so I'm also doing the C button on my keyboard to make a bunch of copies. The other thing you see in the action bar is delete. I can click that and I can get rid of the canvas, hitting delete there as well. But the other piece to point out is in the action bar, there are specific actions that will appear based on the tile you have selected. So here, when I click on this polygon, one option is cut. So I'm going to click on cut, and you see my cursor changes into this plus, and I can click and drag and draw a dotted line to cut this polygon into pieces. I can cut through a couple of the polygons at once and change this hexagon into lots of different pieces. So that is super fun, a really helpful tool for exploring all sorts of ideas of preserving area of a shape when you cut it up into pieces. I'll share some examples of that in a little bit. But let me move on by adding some other polygons to the canvas. I'm going to add a blue square. And what I want to point out is there's smart snapping of the polygons. So you can see as I drag this square a little bit closer, it kind of snaps into place. I can rotate the square. As I click and drag, you can see above the handle the number of degrees of the rotation. So I can rotate it like this, and then it'll snap in place as well. So I'm going to copy this. I'm just doing the C button on my keyboard to copy it a bunch. I'm going to pan down the canvas to give myself a little bit more room. I want to surround this hexagon with squares. At any point during the webinar, if you have questions, please put them in the chat. I might answer the questions in the moment or come back to them at the end. I did a select all to copy this, or to select all of it. Now I'm going to copy it with the C button and put one at the bottom, zoom out a little bit. And the other thing I want to show you with polygons is the join feature. So I've made this nice shape of hexagons and squares. I don't want to cut it. I want to join it. And when I join it, I make one nice polygon. So now this shape is a polygon that I can move. I can rotate it. I can change its color if I want to. Let's make it red. And now I want to cut it. I'm going to try to cut it right across the middle. I think I missed a little bit, but I'll show you that we can cut it into pieces. I could flip this around and see if I made a line of symmetry. Was that cut a line of symmetry? Let's make this blue. The other option in the color is I can go to these sliders and make it transparent. So I'll stop around 50. And you can see when I do that, it makes this purple color, which is really nice. And it seems like I did. Oh, I missed a little bit. You can see a little red sticking out. So my cut was not exactly halfway, but close enough to show you what I can do there. I'm hitting Command Z to undo this action because I want to go back to this shape. I want to take this again. And in addition to the cut, which I showed you, and the join, the other really exciting option to do with our polygons is this fold net. So watch what happens when I do fold net here. I'm going to click fold net, and those polygons come together to make a hexagonal prism that doesn't have a top. So I can use this slider to begin to unfold it, and then I will. So now it's this joined thing that I can move around the canvas. But if I click unfold, it now becomes polygons that I can move around again. So I'll copy this hexagon, put it up here, and make a prism with a top. I find this fold feature a really powerful tool in Polypad. I know I, as a learner, and my students as learners have trouble visualizing what happens when you fold nets into 3D objects, and to be able to visualize this on Polypad is really helpful. Of course, it works for all sorts of shapes. I could build a net with squares. I'm, again, using the C button on my keyboard to build this net. Let me go up a little bit, and I could fold this, and it makes a square. I show this to my students. I build one, and then I do something like this, and I do one fold, and I say, what if I do this? What do you think is going to happen here? And they make a prediction and talk about it, and then we fold it, and we can see that makes like half of a box. And then I just say, go find all the nets of cubes that you can. And they're off and running on a Polypad, going and finding all the nets of cubes. So that's a general introduction to these polygons here. Again, all of these polygons at the top here are ones that you can put on the canvas. You can rotate. You can change the color of them. You can cut them, but you can't change the size of them. And so these polygons at the bottom that have this white handle are ones you can change the size of. So let me show you a quick example of why changing the size might be a little bit helpful. And I'm going to I'm going to clear this canvas, and one way to do it, I'm just going to go to the top. I'm going to click on Polypad. It'll ask me if I want to save these changes. I don't want to because I'm just exploring here. Hit discard, and I have a blank canvas. I want to use this one, that's a rectangle, that this black handle allows me to make any size rectangle that I want. I'm going to turn on a grid background. So this is our first time on the settings bar on the right, and one of the options is grid and display. So I'll turn this on and have this rectangle snap to the grid points. Right, so there's a rectangle. Maybe I want to make a parallelogram and have students explore area of parallelograms. So this one is the custom rectangle. This one that is the green polygon starts as a pentagon. You can see it has 5 vertices. And these vertices I can drag in place as I like. But if I want to get rid of a vertex, I want to make a parallelogram, so I want to have 4 of them, I click on a vertex and it goes away. And just to show you, here's my parallelogram. I'm happy with that. But if I want to make a different shape with more vertices, I can click on a side length here and it adds a vertex. So I really can make any sort of polygon that I want by adding and removing the number of vertices that I like. So I'm going to go back to the parallelogram. And let's say I'm creating a workspace for students with a lot of parallelograms. I've made one that I like. I don't want them to mess up the parallelogram by mistake, to change the size of the parallelogram. And so what I would do as a teacher, I would click this option that says fix vertices. So I'm going to click it, and now it becomes this like a polygon like the other polygons where I can rotate it, I can move it, I can change the color, but I can't move the vertices around. And so that opens the door up to all these moves that I've done, and you've probably done if you've explored the area of parallelograms, where you cut this and move the triangle over here, right? And I've done this for years in middle school with graph paper and cutting and using tape and glue and moving it around. And I find that at times when I do that activity in middle school, the craftiness of it almost gets in the way of the mathematics. And while I thought my students might enjoy the cutting and the gluing and the pasting, they don't enjoy it as much as I think. And it distracts from the idea of the preservation of area when cutting off some area and moving it, where to be able to do it on Polypad really easily and do just this nice cut. Oh, I missed. Let me try one more time. Do this nice cut and move it over is a really much cleaner experience for students. I found it more engaging for them, and really then gets the focus on the mathematics, that this parallelogram, we arranged it into, I think this one I've made as a square, and then we can talk about the base and height of that shape. Let me share one more example of where I think using these tools can help you think about the area of shapes as a way to highlight some of the other tools on Polypad. So I'm going to go back to a blank Polypad, and I want to think about squares and circles a little bit. So there are all these polygons here that help us explore ideas in geometry. The other tool is at the bottom on the toolbar, and there are construction tools down here. So I'm going to click on these construction tools. I actually do want my grid background back on. And I'm going to draw a 6x6, a rectangle. So I'm going to click on the rectangle, and now I get this dot. And when I click and drag this dot, you can see that I can make a rectangle. So I think that is 6x6. There's my 6x6 rectangle. And then I'm going to draw a circle that also has like, a radius of 3. So this like rectangle, I'm going to think of like having a radius of 3, and I'm going to do the same thing with a circle, right? So I would have my students build this, and we talk about, all right, let's put a rectangle inside this square. So I'm gonna put a rectangle here, and I would tell them that I want that rectangle to start at the center and go to the corner, and ask sort of like a obvious question for my 6th or 7th graders: how many of these squares does it take to fill up the big square, right? And we can use the copy feature if needed, and they would very quickly see that it takes 4 of them, right? No surprise, but it's good to actually do it. And by copying that square and moving it around, they're building a really clear picture of what we're about to do next. And you probably see where I'm going. Oh, I moved that square by mistake. The follow-up question is, how many of these squares does it take to fill up the circle, right? And so now we're exploring a much deeper mathematical idea that can begin to go down the road of the area of a circle. I'm just going to make all of these different colors. And again, this is an idea I've explored on paper before, and it just becomes a mess of trying to cut off all these little pieces. But now what I can do on Polypad, I can cut this, right? And so there's a triangle that I can put up here. Certainly, I've skipped the conversation that I would do with students. Does it take 1 square? No. More? 2? More than 2? Not sure about 3. Definitely more than 4 to cover it up. So let's see how these extra bits of the 3 squares can fill up the white space, right? And because all of these squares are the same, I could actually take this triangle and copy it and make it the color of the one that's over here, right? I think I made that one that color, right? And then I could make another one. I could flip it and spin it and make that the orange one. But again, you're all watching me do this now. The power of this is students are doing it for themselves. So they're all approaching cutting this up in lots of different ways. And through that exploration, they're seeing that 3 of these squares don't quite fill up the circle. That's going to take a little bit more than 3. And then we can go down the road of really exploring where the formula for the area of a circle comes from. I've stopped cutting it up, but I just want to show you one that I made in advance of this webinar. So I've been in the tile menu here. I'm going to go to the file menu where you can save polypads. I'll show you how to do that in our next exploration, but I just want to pull up the one that I made here. So these are all of my saved polypads here. I'm going to discard this. And there's one that you can see that I went through and I took my time and I cut up all the pieces. There's some overlapping going on, right? I should probably move this one down a little bit. And this one looks to be overlapping. So I could be more precise if I wanted to. But there's enough like white space left over that it opens up that conversation with students of like, it seems like it's going to take a little bit more than 3 of these squares to fill in the circle. And then we can go down the road of all the other ways to prove that it's exactly 3.14 squares of them. So it is already 17 minutes into the webinar, and I'm still just on the polygon section. And part of the joy of Polypad is there are so many wonderful ways to explore all these tiles. I'm not going to go through all of them in the webinar. In fact, I'm going to jump right now to the numbers section. Let me just give you a sneak peek of the other tiles we have here in geometry. Pentominoes and tetrominoes, tangrams, Penrose tiles. Students can make all sorts of beautiful artistic creations and tessellations with the Penrose tiles. There are pentagon tiles, some pre-made examples of objects that can be folded and unfolded, as I showed you. We have a ruler, protractor, set, triangle, and compass, and some more ways to explore patterns in art. And you might be thinking to yourself, slow down, Dave, I want to learn more about all these geometry things. Yes, I could spend the whole hour talking about geometry. So maybe if you teach geometry and you want to learn more about it, let me show you 2 things that you can do after the webinar to go learn more. First, you might notice there's a question mark right here, and that's going to open up our geometry instructions page. So I click on that, and this is a user guide of all the tiles in the geometry section. So if you're like, pentagon tilings, what was that about? You could scroll down, and here is a brief introduction and example of what you can do with the pentagon tiling. So you can go explore this. That is, again, this question mark is our user guide on geometry. The other place to go, I'm going to click on the question mark on the right-hand side here, and that's going to open up a help and support page. And this help and tutorials link is going to go to mathigon.org/learn. I'm going to drop that in the chat as well. And mathigon.org/learn is a great place to start to go learn about anything you want about Mathigon and Polypad. And you could go to our webinars here. And as I was mentioning at the beginning, there's a webinar on most topics. So if you want more geometry in this webinar that I'm giving you, you could go watch the webinar from this spring on exploring geometry. Speed it up. You could jump around, but those are places to go learn more. Both the question mark next to each tile type, as well as mathigon.org/learn. All right, let me jump to the number section. I did a webinar last week, Polypad Introduction at the elementary level, And so if you weren't able to make that one and you are an elementary school teacher and you want to learn about all of these number tiles that help students make sense of numbers and number frames, go check out that webinar on our YouTube channel. You can find it there, and it'll soon be on mathigon.org/learn. But one of my favorite things to do as a middle school teacher with the number tiles is make double number lines. So I'm going to share an example of how to make a double number line with percents, how to save it, and then how to share it with students and view their work. So all through this example, I'm going to do a brief exploration into the teacher tools as well. So I'm going to go to the number line section, and I'm going to click to add a number line to the canvas. I'm going to zoom in a little bit. And you can see here, when you click on the number line, I could change what the number line starts at. I could start at 10. I could go up by a half. I could start at 2/3 and go up by 1/3 every time. I could start at pi and go up by 2 pi, all sorts of great features to change the labels on the number line. But for this example, I want to do a double number line with percents. So I've done my start as 0 and my step is at 10%. And I want this to be the top number line of my double number line. So I want these labels to be above it. And so I haven't shown you the gear yet in the action bar. We've explored that how every tile has options specific to that tile type, but every tile also has this gear where you can find more advanced options of that tile type. And one option I want to do here is have the labels be above it. So I click that and the labels are above the number line. I'm going to turn on my grid background so it can kind of snap in place. There we go. This number line has a width of 2, which matches up with the large grid on the background. You can see if I make the width, if I change that to 1, it'll make the number line smaller and condensed. I want a number line of 2. There we go. And I want to put another number line below it. And what I actually want on this number line for my students is just the number 0 and a number at the end. And we currently don't have the option to turn off some labels and not the others. That might be coming soon. So for now, as a workaround, I'm going to have no labels here. And then I'm going to go down to the equation editor. You can see there's text boxes and equation editor. Equation editor just allows me to type in a number. So I'll do 0 here. And I want the 100%, I think for the example that I've made, is 340. So I'll make this 340. So there I've labeled the beginning and the end of the number line, right? And I want to have my students figure out what 40% of 340 is. And so I'll put a little question mark here in a second. But the other visual that I think is really nice to help students make sense of this is putting in a fraction bar. So we have our tenths fraction bars. I'm going to turn off the labels here. I don't really need those labels. So I'll do no labels. And on these fraction bars, the black handle changes the size of the fraction bar, but the black triangle changes the amount that is shaded in. So there's a nice visual of 40%. And then I want to put a blank here for my students to fill in. So I have a teacher account. I'm logged in my Mathigon account, and I've made a teacher account. And because I'm in a teacher account, under games and applications, the last category is called question builder. If you are not logged into a Mathigon account or you have a student account, this is not going to appear. It's very easy to change your account type. If you made a student account and you want to switch it, you can go up to your name here and click on account settings. And one of the options will be to switch from a teacher to a student account. So because I'm in a teacher account, I can add this little box to the canvas, which is like a question box. I'm going to make it a little bit smaller. And 40% of 340, I think is 136. I've done it in advance, but 10% is 34. So yeah, I think 136. So I'm going to type this in as 136. That's the answer. But when I share this with my students, it's not going to show the answer. I'm setting up like the answer key guide here. So now I'm going to go to File. I want to save this. So I actually need to duplicate it because I started off on my other canvas. If I hit save now, it'll override the wonderful example that I made with the circle. So I'm going to do like duplicate. So now it did a save as, and I'm just going to call this % example. I put a Z in the front, so it'll be at the bottom of all of my list of saved polypads. So I save it. You can see all of these folders here are my saved polypads in my account. There are some that I don't have in folders, like this one all the way at the bottom. There it is, Z% number line. So there's the polypad that I've made. And now so many ways to share this with people. I could copy the link here, right? That URL is copied to the clipboard. I could go up here and just do Command C. I'm going to paste this link in the chat so you can open it. And when you open it, you'll see there'll be a little question mark there for the 136. There's a little bug right now that if you're also in a teacher account, it might show the answer. We are fixing that. Hopefully when you're watching this after the fact, it is fixed. I also could take that link and assign it to my Google Classroom, to my LMS. You can see here when I went to the share button, there's a pop-up for Google Classroom. So I could make an assignment right there in Google Classroom. But I actually have made Mathigon classes. I'll show you how to do that in a minute. I'm going to share this with my Mathigon class. So I'm going to go up to the class tab. And in this account, I just have a few classes in my account for school. I have all my classes synced right up to Google Classroom. I want to share it to the webinar example class, and I'm going to click Assign. So I've shared it with that class. I have one student in that webinar example class. It's my daughter's Polypad account. So I'm going to swipe over to a different browser where I'm logged in as her and see what happens. So I'm going to swipe over. Here we are. There we are. And you can see I'm logged in as my daughter, Emily Poras. I'll just give it a refresh. I'm going to go to the File menu. And you see she has a folder called Assignments. So I open that folder, and there it is, Z% example. So that got shared with her, and there is the question mark. So now she, as a student, gets this. If I were doing this for a class, I'd probably have a number of examples on it. But let's say she's doing it, and she's like, all right, well, I want to know what half of 340 is. So I'm going to pretend to be her and show off some of our other tile types in the number section. One of my favorite tile types is these prime factor circles. If you've played the game Prime Climb from Dan Finkel over at Math for Love, you're familiar with how these prime factor circles work. You can take like 18, but here, interactively, you can pull it apart into its prime factors. So I can pull apart the 18 into the 2, 2, and 3, and if I add an 11 onto the canvas, I can combine them. There's 33 and 99. So these prime factor circles show the prime factorization of numbers based on colors, but the ability to pull them apart and put them back together is a really awesome feature. So for these purposes, maybe my daughter is like, I want to know what half of 340 is. So she's going to do that with a prime factor circle and pull out a 2. So half of 340 is 170. So maybe she'll label this 170 at the halfway point. Maybe as a 7th grader, she would know that 10% is 34, and then she just wants to do 170 minus 34. I'll use this opportunity to show off our number cards here. So on the prime factor circles, when you put them together, it's the product of them, right? On these number cards, when you combine number cards and put them on top of each other, it finds the sum of the number cards. So I've noticed my students sometimes will use those for a quick subtraction problem. So here's 170, and I can type in negative 34, right? And I put those together, and I see that it's 136. So then I type in 136. Oh, I got it wrong. I typed in 135. I get this red X when it's wrong. So let me fix that, 136. I get this check mark, confetti comes down the screen, and my daughter's now going to save her work. So she's finished this. She hits save. We have some auto-save features in development. But there she is. She's done with this canvas. I want to show you now on the teacher end what happens. So now here I am back as a teacher. I'm going to hit a reload, and there you can see my daughter's canvas. I can click on it, and I can have that appear on my screen. Right? I can have names appear or not. Again, this class just has one student. Imagine a class of 25 or so. You could see all of their work. And as this is projected, I love to have names on or off. And, this one is the assignment. That's like the blank assignment. And here is student work. And I could have this up on the screen, and I could say, hey, Emily, can you share with us what the 170 is about, right? And what's the 34 about? And she could use this up there to talk about her process. This is orange here. That tells me as a teacher, she got all the questions correct, but it took multiple attempts to get them correct. There was only one here, but you could have a Polypad with multiple of those boxes to fill in. And so in the assignment, you could add a bunch of them here. All right. So those are the number tools, a really fast example of the number tiles. If you have any questions along the way, please drop them in the chat. Let me head to mathigon.org/learn for a minute, because I want to show you on our tutorial tab. These are all the user guides, but there are short videos. Most of them are about 5 or 6 minutes of how to make classes in Mathigon, how to add students to the classes, how to share Polypads with students. So all of those things I just did, where I showed you that I had a class and I used the question builder tool. If you're interested in learning more about those features, going to these short video tutorials would be a really nice place to go. All right, awesome. So those are the numbers. Let me keep going to some other tile types, and I'll come back to some other number things if there's time. But one of the most powerful tools on Polypad at the secondary level and the elementary level is our balance scale. So I want to spend a few minutes talking about the algebra tiles and how the balance scale works. So this is a scale. One of the really wonderful features about the balance scale is almost every tile on Polypad works on the balance scale. So I can go to the number section, and this is a 10 tile, so that has a value of 10. I can expand the size of the balance scale with that circle. So there's 10. Our number bars, let's do a 4 and a 7. That'll make it bigger, right? There's 11, but I could balance that off with a 1. So now it's balanced on these number frames. I could add pieces to the number frames, right? There's a 7 and a 10. So I need to balance that with a 3. Hopefully that should balance things as well, right? So you can keep adding things on to the scale here to balance it. It works with the prime factor circles as well. So I could do a 10 on this side, and then let's do a number card of 10 over here. It works with fractions. So I showed you the fraction bars before, but we have these fraction circles. So a fifth should balance with 2/10, right? So that balances. So wonderful explorations that you can make with students with the number tiles on the balance scale. It also works with our probability tools. So I'm going to put another balance scale here on the canvas, right? So there's a balance scale. I'm going to go to probability and data, and let's add a set of playing cards onto the canvas. I'm going to zoom out a little bit to give myself a little room. So here is a stack of playing cards. I'm going to shuffle them up. You'll hear a shuffle sound effect. There we go. I'm going to draw the first card, not look at it. Draw the second card, not look at it. And let me put, I'll put some dice on the canvas. I'll put 2 10-sided dice on the canvas. So there is 16. So those 2 cards are more than 16. I roll them again. 16 again, not helpful. Let's see if we can get something helpful. More than 6, not helpful. Oh, it balances with 18. That was really exciting. You can see right in one roll it balanced with 18, just to show you that that's like too big, right? And then we could do further explorations to figure out what those cards were. It's a 7 and a jack, because a jack is worth 11, and so on. So fun explorations you can do with the dice and the cards and the numbers. But let's get into some algebraic thinking with these tools. I think as a group of secondary teachers, you might want to think about how to explore some algebraic thinking with these. So let me show you the algebra tiles. And the first thing I want to point out is the default value of the X tile is 5. That's just what we chose when building this. So X is worth 5, the X tile is worth 5, and the Y tile is worth 4. So you'll see when I put a 4 here, that balances with 9. But certainly we don't always want X to be 5 and Y to be 4, as we want students to think about equations to solve on the balance scale. We want them to be a variety of different things. So I'm going to walk through an example of how I use the balance scale to have students build and solve equations. And the first one I'm going to do is one that is from a tape diagram. So here's a tape diagram I built on Polypad. I'm going to put this link in the chat here so you can play around with it if you want. This would certainly not be the first one I would do with students, right? We'd start with much smaller, how to use the tools, how to build up from here. But as an example for a webinar, I think it's a good place to start. The first thing that I want to point out is this is totally locked, right? If you open this Polypad or you watch me doing it, I can't click on the numbers, I can't click on the bars, it is like stuck. So I do that so students can't like mess it up by mistake. They can figure out ways to mess it up if they really want to, but if they hit delete by mistake, that's not going to happen. So my instructions to them are build this on a balance scale and find the value of x. And again, this is not the first time, right? They've interacted with the balance scale. They get how it works, but I just want to use this as an example. So they would go to the algebra tiles and they would say, all right, well, we have 3x plus 2. So there's 3x. And then we'll go to the number cards and put a 2 here. And there are 3 groups of those. And I tell them the first time they do it, I want the picture on the scale to match up exactly what's in the tape diagram. And I think there's great value for them in building this, right? So they're looking at the tape diagram and thinking about how to represent that. If they want to, they could make this all green, right, to match up the picture. And then they put a 40 over here. 40, and it balances with 50. Right? And at first, they're like, great. Oh, but it didn't balance. There are some that make the 50 red, right? And it didn't balance because, as you may know, I said the starting value of x is 5. And so what's this? 15 and 2 is 17. So that's 51. That's 91, right? This is 91 right now. Just to show you that, if I did my arithmetic correct, does this balance with 91? Yes, it does, right? But I don't want it to balance with 91. I want it to balance with 50. And so the way to do that is when I click on the balance scale, and at this point, students know this, right? So they click on the balance scale, and now when I click balance, Polypad is going to assign the value to the X tile that will balance the scale. And that will stay on this canvas. So anytime now this, if I save my work, I'm not going to do it because this is my example canvas, right? But if a student were to save their work, X will always have that value. So watch what happens. I click balance, oh, and it balances. I encourage my students to make that sound effect when it balances, right? You click balance, and it's like, oh. And I like this example because for many middle schoolers working with equations, it's not obvious what X is right now. It's not like a 2x plus 10 equals 20, right? Something that they could think through in their head after a little bit of work with solving equations. So now they're off and running. I would, at some point, have my students also represent the work algebraically. So 3x plus 2 plus 40 equals 50. So they'd have this on the canvas, make it bigger. And they'd start doing moves to try to figure out what x equals. So one thing that I really like about this is when I move the 40 over here, it stays 40 and it's no longer balanced, right? I did not preserve equality by moving the 40 over here. There are some other ed tech tools where when you do that, it automatically changes into negative 40. I like here that it doesn't do that automatically for students. They have to think about what's happening, right? And so I will have the students talk about, all right, well, let's get rid of that. We can add a negative 40 over here. And in fact, like what should happen to the side of the scale when I drop on a negative 40? Well, it gets lighter, right? Because we added a negative. And when I do it over here, it's balanced, right? And so now I'm only going to do this for the first step with the algebra. But what I would have the students do here is write plus negative 40. And then here they'd write plus negative 40 to show in the algebra what they're doing at each step. And then we put these on top of each other and it makes this nice 0. And I love that it shows that 0, so students have to actually like get rid of the 0. I should have actually mentioned that there are some students here would not want to do the 40. They'd want to do this, right? 2, 4, 6, and then put all these x tiles together. So they decided to distribute first. So on their next line, they would have 9x plus 6, right? So that's I like that this tool can allow the students to solve that equation in lots of different ways. So I can make that 46 and then put negative 46 on each side, right? There we go. And then we have that 9x equals 4. And some students might know right away that it's 4/9, and they could do that. But I also want to take this opportunity to show our fraction bars. I think there are some really nice features of our fraction bars to help students think about what does it mean to split this into 9 groups. I mean, that's pretty clear. I'm splitting this up into 9 groups. I could spread them all out if I wanted to. But what about taking 4 and splitting it up into 9 groups? So I'm going to go to our full fraction bar and copy 4 of them here. So there's 2, 3, 4, right? And this is hard to split up into 9s because it's still wholes. But one really nice feature on the fraction bar is a rename option. So I'm going to click this, and you can see as I do it, it's splitting the fraction bar up into pieces. So there I've split it up into 9ths, and it's this really nice visual of how it matches up with the algebra tiles. And then I can select all of these and click split in the action bar. And that's split. I hit split and then rename again. Let me just show that one more time. Now there are all of these fraction bars. I hit split, and now there are all these individual pieces. So I could show that this group, right, I can kind of spread out, and this group I can spread out. And when I remove that and remove that, x balances with 4/9. Right, but again, if students just knew that, if they got to the point where they were like 4 divided by 9 is 4/9, they can go to the equation tool and just type in a fraction, and this will also balance it on the scale as well. So there we've got that x equals 4/9. Right. Take this opportunity to show you that it tells me on the canvas what this decimal is, right? 4/9 is 0.444. Sometimes I don't want students to have that feature turned on, and so this is the first opportunity to show you the Customize UI menu. So UI stands for the user interface. You can customize the interface you want your students to have. And one of the options is evaluate equations. So I'm going to turn this off. I'm going to uncheck it, hit apply, and now you can see it just has 4/9 on the canvas. All right, so there's an example of the tape diagram, which I think is a nice way to build an equation and solve it on the canvas. Let me go to a new Polypad. I don't want to save changes because I use this canvas as a template a lot, but if this were a student, they would cancel and save it so then you as a teacher could see their work. One more thing on algebra before we dive into probability and data. I just want to show you some of our variable sliders. So where are we here? Variable sliders. I'm going to put an A and a B on the canvas. And these, I can hit play and the value of A and B is changing as I do that. I'm going to pause them both. I want to set them to go from a range of -20 to 20. And under the gear, I can change what they go up by. I want them to be an integer from -20 to 20. So my increment is 1. And now when I hit play, you can see that it is stopping at integers. So now I'm going to go to my equation tool, and I'm going to make an expression, 4a plus 2b plus 7. So there's an expression. I'll make this bigger for us here. And you can see it tells us that is 33. 30 plus -14, or 40 plus -14 plus 7 is 33. And as I click play, you can see that that's changing. And I think that's just a really nice visual for students to build on their own and play, and getting this idea of like evaluating algebraic expressions. As the variables change, the expression constantly changes as well. But I could turn this off, right? As I showed you in Customize UI, I could turn this off. And then I could have students try to find the value of that expression. And again, the balance scale is really handy here because I can copy this and put it on one side of the scale and try to evaluate it on the other side of the scale. Oops, I did a wrong scroll here. There we are. All right. And if I go to the tile menu and build this, maybe I build it with number cards and show that it's 4 8s. I don't want those to merge. I actually want to show the 4 8s and 2 -12s. Right? So there's the 2 -12s and then a 7. And that should balance. Right? Nice. Yeah, it balances. I could put all those tiles together to find the number, but I'm more interested in exploring with students when I hit play and we want to do it again, what has to change and what doesn't have to change, right? So we hit play again, and when I stop, I'll try to stop at, some different numbers. Ooh, now negative 17 and 12. So now I need this to be negative 17. So all of these 8s become a negative 17. Oops, again, merged again by accident. So there's 4 negative 17s. These are positive 12s. I can do a shortcut and just hit negate and make those positive, and there's the 7. Right? And so building the idea, just through a couple examples here, right, that this 7 doesn't need to change, right, that it's just the A and the B that are changing. The 7 is the constant. And having a visual, having students do a few examples of this, I think will cause them, when then they just see it on paper and are thinking more abstractly, to help them make more sense of what's happening in the abstract. So that, I think, can be helpful as well. Those are our sliders. Again, you can click on the algebra section to learn more about all the algebra tools. The last thing I want to show you in the final 15 minutes or so is some of our probability and charting options. But I'm going to pause for a second and show you our lessons page. So I'm going to keep this tab open. And now I'm at mathigon.org/learn that I've shown you a few times. But at the very top, I'm going to click on lessons. And this is a growing library of lesson plans and puzzles and games and teaching ideas. So if I search for, fractions, you can see there's a number of categories on fractions, how to explore all operations with fractions. I know there is a lesson on a few lessons on using algebra tiles with quadratics that you might want to explore. There's one on completing the square, how to use the algebra tiles for completing the square. You could search by topic. I can type in algebra, and all of the lesson plans that have some connection with algebraic thinking appear, or you could just scroll through, right? So I encourage you, as you're thinking about ways to incorporate Polypad into your teaching, check out the lesson page as well. All right, not seeing any questions in the chat. Keep them coming if you have them. Feel free to jump in the chat and ask any questions. I'm going to select all that and clear it and show you our probability tools. I showed you a few of them, but I want to just go to coins, dice, and spinners. I'm going to put a dice on the canvas. I can roll it. I can double click to roll it. But what is really powerful here is the ease in which I can put a lot of dice on the canvas. So there's 5 of them. I can copy those 5. There's 10 of them. I can roll them all at once, which is really fun. I can copy that. There's 20. There's 40. There's 80. I want to get to 100. And so I think there is 100 dice, right? Just in a matter of 10 seconds, I have 100 dice on the canvas. And so I love just doing that and saying to the class, how many 6s do you think are going to come up? And they can make a prediction, and I could roll it, and we could go through and count the number of 6s, right? Great introduction just to thinking about dice. But notice this tabulate button. So I'm going to click tabulate, and I get this chart that actually has counted for me. So this time I had 15 6s. Let's do it again. I'm going to roll, and now I got 13 6s, less. And I'm going to do it again, and 15 6s. We could keep going, right? Or I might want like a running tally of the number of 6s. And so we've talked about this gear is often a place to look if you want to change the settings of a tile. And you can see right now I'm in replace mode. But if I go to accumulative mode, every time I roll, it'll add to that. So now I have 32 6s in total and 47. So that can keep going. I also want to point out these charting options down here. So from a table, you can automatically make a chart. So I click on the column chart, and notice I automatically get this chart of the numbers that I've rolled. So right now I've gotten more 2s than 4s than anything else. As I keep rolling, those bars will change, right? So really easy to both tabulate and graph data. And this works for basically all of the tiles here that have, a random feature to them. So I can flip all the coins, and I could tabulate that. I could flip them again and tabulate, which I think is a great question. Can you co-figure the dice so the 1 appears more than 1/6 of the time? It is not customizable yet. That is a feature request that we've gotten a lot and is on our list of wonderful ideas from teachers that we hope to include at some point. So not there yet, but stay tuned and keep sharing the ideas, because we love hearing from teachers about ways you can do that. One way that I find really powerful is using this to generate lots and lots and lots of data. So I'm going to go to the file menu here, and I'm going to go all the way down past my polypads, and there's a section that appears for everyone called examples and templates. And so these are pre-made canvases that you might find useful. So I'm going to open the probability and data one, and open one that's 50 sets of 3 coins. So here are 50 sets of 3 coins. And my question for students before we had really explored probability was, how many times do you think of these 50 it's going to be star, star, star? So we would flip them, and you can see I have 1, 2, 3, 4, 5. I'm sure I missed some. And we could do it again. How many are star, star, star? And we made some predictions. And then my task for students was go do this canvas. This has 50 of them. I think I had each student do it 10 times. Now, that's 500, if I'm doing my arithmetic correct, 500 flips of 3 coins. If I had ever asked my students to actually flip 3 coins 500 times, never would have done it. It's painful, right? They might have had fun the first couple and then would have lost interest really quickly. But doing this 10 times is almost enjoyable. They have fun doing it. They have fun predicting how many stars they're going to get. They put all their they keep track of all their data, how many of the 50 had star, star, star. And at the end, I asked them to share that data back to the class. And I type them into a Google Sheet as they're doing it. So here are all the numbers that students shared with the class. So this, I think I got up to 200 or so in this class, so 195. So maybe I only had each student do it 4 or 5 times. But in 4 or 5 times of 50 on that canvas, we generated a data set of almost 10,000 flips of 3 coins. And it was a big enough data set that students believed it because they were actually doing it, right? They actually flipped the coins and counted. And so when they had their number, they believed it. And when their classmates had their number, their classmates believed it. And therefore, when our experimental probability was 0.1247, and the probability of this is 1/8, which is 0.125. When we then went through either the list or the probability tree and saw that the theoretical probability is 1/8, and we compared that to our experimental probability, there was ownership in the ways that we calculated the experimental probability. And I think that's really powerful, for students to do. Certainly there are codes that you could write that might say, roll 3 coins 10,000 times and tell me how many of them were, tails, tails, tails. But again, I think the power of students being able to do it and see it for themselves adds a lot of belief to the probability. And so I've done this with 100 pairs of coins, right? Like how many double sixes are going to come up, and being able to do it really joyfully on one canvas, I think is fun for students. So those are some of the data tools. I've showed you a little bit of our charting tools, but I just want to share a quick example from our task page. And so I'm going to go to our task page, and I want to pull up this lesson plan. And I'm not going to read the lesson plan. I'm just using this to find this canvas. And I'm using this as a way to show how you can use charting in Polypad to create a slow reveal graph. So if you haven't been to Slow Reveal Graphs, great website, great routine for having students think mathematically about what graphs can represent. This is a bar graph that I've made on Polypad. You can go here to charts and statistics and hit this question mark to learn how to make a bar graph. You saw it in the table where I had data in a table and clicked bar graph, and it just makes the chart. So it's just that easy. But here in the notice and wonder routine of a slow reveal graph, you'd have students just make some guesses about what this graph could be. But one thing that I really like is I've covered up the data with this polygon, right? So I used the rectangle polygon and made it green to cover up the table. And what you can do in the table is as I click and drag, I can go from one column to two columns. And so in doing this, it shows a really nice like visual of what's happening in this bar chart. And then I might show the x-axis that says 2010, 2020. And then, I might do this change from 2010 to 2020. And maybe they're making some guesses about what that might be. And then I could hit delete on that one and show that now it's going from 0 to 100. So now, what could that be? And at each point in the routine of a slow reveal graph, you have conversations in small groups and as a class about what students are thinking that could be. Hit delete here, and you see the data, and then I can back up again, and you can see that each of the categories is it's from the census from 2020, how people who completed the census, how they identified, and then the final reveal, this was in Nevada, and you can see that the big shift in Nevada was in the red category, which was the white alone, not Hispanic or Latino. And you may know there's a pretty significant shift in the demographics of Nevada from 2010 to 2020. So interesting conversation, as well as I think it shows a nice way to use the tools of a slow reveal graph. So let me go back to Polypad. Again, that was in the probability and data, charts, and statistics. So I just made a column chart, but you can make line charts, area charts, pie charts, box and whisker. You can graph things as well. I should show you, I didn't get to it in the algebra section, but let me go to it right now. Here is a coordinate grid. I can add an equation onto the canvas, y equals 4x plus 2. So there's my equation. Anytime that you see something with a blue triangle, it's a it's a wire that can be used to connect two things on Polypad. And you can see that when I took the equation and connected it to the graph, that line has been graphed. And so I also could attach a slider to this. And so instead of 4x, I'm going to make this a times x. And now as I hit play, the slope of that line is changing, right? So just like you can do on the Desmos graphing calculator with a slider, the same kind of functionality here that can help students explore what those things might mean. It is 1:57. I have talked almost the full hour. Let me end by thanking you for sticking with me at this webinar. And I barely scratched the surface. I hope this webinar kind of piqued your interest about all the ways that you can use some of these tools to engage your students in math exploration and discovery. A few things that I want to close with. Some great places to go as ways to learn more. Mathigon.org/learn has these getting started pages, has Polypad user guides, has these videos about how to make classes, how to share Polypads with students, and then go to the webinars tab. And depending on what you might be teaching this upcoming school year, you might want to do a deep dive into our logic and computing. We have all these under games and applications, we have a whole logic and computing section. You can make music with our logic and computing. I didn't even talk about, so go watch the logic and computing webinar or the exploring probability webinar. And be sure to continue to come back here to sign up for any upcoming webinars. Here you are at our summer webinar series. There are 2 more in August, but over the course of the school year, I'll be doing additional webinars on these topics. And be sure you are signed up to receive our Mathigon newsletter. So we're sending about once a month, not a lot of emails, but if you go to account settings, make sure you have checked this. Please send me occasional emails about new content and functionality so you can stay up to date. And give us a follow on our social media channels, Twitter and Facebook and Instagram. And please tag us with how you are using Polypad in the classroom. We love seeing how teachers are using Polypad. If you have ideas, please share them there as well. And my final thing, I just want to go to our activities page. I didn't even mention any of the activities. There's a whole other branch of Mathigon. Again, everything is free with a timeline of mathematics. a puzzle page, an almanac of interesting numbers, all sorts of great things to explore. So go check that out as well. Wonderful. I will stop there. If people have any other questions, I'm happy to stick around and answer them in the chat. But thank you for coming and checking out this webinar. I hope you found it a good use of your time, and I look forward to seeing you at future events down the road. Thank you for coming, everyone. Take care. I'll keep it open for a minute if any questions come up. My pleasure. Yeah, thanks everyone for the thanks in the chat. I'm glad it was a helpful overview. That was the goal. If you have suggestions about improvements, feel free to shoot me an email or message me on social media. If you think this webinar could be improved, I would love your feedback as well. All right, I'll give us another few more seconds for questions. Otherwise, I will end the live stream. All right, thanks everybody. Have a great rest of your day or night or morning, wherever you are. And look forward to seeing ways that you use Polypad in your classroom. Please share so we can all learn together. Thanks very much. Bye-bye.